between. It can happen anytime between 5:47 a.m. and 10 seconds to 6:36 a.m. and 33 seconds. Now, there's a star called T Coronae Borealis. It's also nicknamed the Blaze Star. It is a binary star. It's a approximately, they say, 3,000 light years recurring nova star in the constellation of Coronae Borealis. It was first discovered in an outburst in 1866 by John Burnham. It may have been observed in 1217 and 1787 as well. In February 1946, a 15-year-old schoolboy from Wales named Michael Woodman observed the flare-up. Subsequently, the Astronomers' Royal Society leading the theory that the star flares every 80 years. So, I'm going to show you some videos here in a bit, and why this is a very serious event, because it could be a cataclysmic event. Now, according to my calculations, this star is going to go supernova tomorrow. All the scientists have been trying to figure out when this is going to go supernova for years now. They've been saying since 2023 and 2024 it was going to go supernova. Now they're saying probably towards the end of 2025. But I believe it's tomorrow. And from what I have read, it could be a cataclysmic event. So I had a dream about this star many years ago. The Lord showed it to me. And it was terrifying. I was terrified. I don't even want to go into the details about my dream, but it's going to be brighter than the sun. It's going to be brighter than the sun. They're saying that it might be, possibly as bright as Polaris, which is the North Star, which is a 2. But this thing is going to be far brighter than that. But not only that, but they're thinking that it goes supernova in the evening. I'm saying it's going to go supernova in the morning. Like I said, 5:47 in the morning. It's going to be the dawn star. The dawn star to usher in the new year, the new era. Okay, so some Jewish people believe that this star is a sign of what they're thinking is going to be the sign of the Mashiach. I've heard that Muslims think it might be a sign for the Mahdi. Of course, I'm saying it's a sign that Jesus is coming soon, which I know that for a fact, because if you've been watching my videos, I've been saying that Jesus is coming this year. So I've already done all the calculations, and I don't want to get into all that with people because they don't understand how my mind operates. But anyway, so let's just go back down over here and watch the videos now.
A new star will appear, and it'll be about as bright as the North Star. Astronomers and amateur astronomers from all over the world will point their telescopes to this event.
NASA scientists say a zombie star will soon rise from the dead. 'Tis the season, right? And this is for the first time in decades. Back in 1946, astronomers watched as a new star suddenly appeared in the night sky, but it faded away after a few days. Now, nearly 80 years later, NASA says it could happen again. Scientists expect the binary star system called the T Coronae Borealis, or Blaze Star, to explode soon. And when that happens, it'll bring one of its stars back from the dead and briefly create a new one. This is fascinating. We asked NASA why the celestial event is important for people here on Earth.
Novae like these are incredibly important because they're producers of elements such as carbon and nitrogen and oxygen. And those elements are not only necessary to make up our Earth, but also to make up the atoms in our own bodies. So these novae are incredibly important for there to be life on Earth.
Yeah, pretty important. The zombie star system is located about 3,000 light years away, but once it explodes, scientists say it could be visible to the naked eye here for about a week.
Looking up at the night sky, you might catch a glimpse of something extraordinary. T Coronae Borealis, a star that could soon burst into life, outshining all its neighbors. We're talking about an incredible event that hasn't happened in nearly 80 years. Known as the Blaze Star, T Coronae Borealis could put on a dazzling show visible to the naked eye for a few nights. And when it happens, trust me, you're not going to want to miss it. So, what makes this star so special? Why are astronomers all over the world eagerly waiting for its big moment? Well, stick around, and we'll dive into the science behind this star's incredible flare-ups, what it can teach us about the universe, and why this is a once-in-a-lifetime opportunity to witness something truly cosmic. Now, let's get into it. T Coronae Borealis, or TCB as astronomers call it, isn't just your average star. In fact, it's not even a single star. We're looking at a binary system, which means two stars are involved. One is a white dwarf, basically a tiny, super dense leftover of a star, and the other is a red giant, which is, well, pretty much what it sounds like, a big, bloated star nearing the end of its life. These two stars are locked in a kind of cosmic tango, orbiting each other in a slow-motion waltz across the galaxy. And here's where things get really interesting. The white dwarf is slowly stealing hydrogen from its red giant companion, pulling it over bit by bit like some kind of stellar pickpocket. But there's a catch. When enough hydrogen piles up on the white dwarf's surface, it reaches a tipping point. And boom, we get a thermonuclear explosion, lighting up the sky in what we call a nova. It's like a massive hydrogen bomb going off, releasing more energy than our sun could in an entire year. Yeah, let that sink in for a second. And here's the kicker. This can happen over and over again. Unlike a supernova, which is a one-and-done kind of event that destroys the star in the process, these recurrent novae, like TCB, can flare up multiple times. T Coronae Borealis has had recorded flare-ups in 1866 and 1946, and some historians think it may have even blown up back in 1217 and 1787. So, what does that mean for us today? Well, buckle up, because the clock is ticking for the next flare, and all signs are pointing to it happening soon. You might be wondering, how do we know it's coming? Great question. Recent observations have shown that TCB began dimming in 2023, a behavior eerily similar to what happened just before its 1946 outburst. That's why astronomers are thinking the next explosion could happen by the end of 2024 or early 2025. Now, this won't just be an awesome light show for stargazers, it's also a treasure trove of data for scientists. Each eruption of TCB provides invaluable insights into the physics of these thermonuclear explosions, helping astronomers refine their models of how stars evolve and interact. Imagine having front-row seats to a real-time cosmic experiment. Every time TCB flares up, it's like getting another piece of the puzzle, helping scientists better understand how stars live, die, and sometimes explode spectacularly. But more than that, studying novae like TCB can even help us unravel bigger mysteries about the universe, like how certain types of stars can eventually go supernova and outshine entire galaxies. Yes, galaxies. It's that big of a deal. Speaking of supernovae, there's another reason why this upcoming eruption is so important. These recurrent novae serve as natural labs for studying the conditions that could lead to something even more cataclysmic, a Type 1a supernova. When a white dwarf like TCB's gobbles up enough mass from its companion, it can reach a critical point and explode with such force that it could outshine the Milky Way itself. These explosions are crucial because they help astronomers measure cosmic distances and understand how the universe is expanding. Now, TCB isn't expected to go supernova anytime soon, but by studying its flare-ups, scientists can better understand the conditions that might push a star to that next level of destruction. And hey, every nova brings us a little closer to figuring out what might make a star finally pop. Let's switch gears for a second. Have you ever thought about how cool it is that we live in a time where technology makes it possible for anyone to be an astronomer? I'm not talking about buying a fancy telescope either. Thanks to tools like binoculars, digital cameras, and even smartphone apps, it's easier than ever to observe celestial events like TCB's flare-up. And who knows? Maybe this event will inspire the next generation of scientists, stargazers, and space enthusiasts. Heck, with a good enough camera, you might even contribute to the scientific study of this event. Imagine telling your friends, "Oh yeah, that data NASA's using? I helped with that." As Dr. Rebecca Honell from NASA's Goddard Space Flight Center pointed out, this once-in-a-lifetime event is expected to cause a surge of interest from amateur astronomers and curious skywatchers alike. When TCB brightens, it'll be visible even from urban areas. So whether you're out in the countryside or in the middle of a city, you've got a chance to witness something that's been brewing for 80 years. So, what exactly triggers a nova eruption? That's the million-dollar question. While we know the general process, hydrogen piles up, reaches a critical point, then ignites like a celestial firecracker, there's still a lot we don't fully understand. For example, what role do magnetic fields play? How does the rate at which the white dwarf siphons off hydrogen affect the timing and intensity of the explosion? These are questions that scientists are still trying to answer, and every nova event offers new clues. Here's the thing though, predicting these eruptions isn't an exact science. Astronomers like Ed Murphy from the University of Virginia are quick to point out that just because TCB is dimming doesn't mean a flare-up is guaranteed. Historical records show that the timing and intensity of these eruptions can vary widely, so while it looks like we're on the verge of a flare, nothing's set in stone. It's this uncertainty that keeps astronomers on their toes, constantly refining their theories and racing to develop better observational tools. And speaking of new tools, the future of astronomy is looking brighter than ever, no pun intended. With the upcoming Vera Rubin Observatory set to become operational in the mid-2020s, we're entering a new era of discovery. This cutting-edge facility will provide continuous full-sky surveys, making it easier than ever to detect transient events like novae. In other words, we're about to get a lot better at spotting these cosmic fireworks before they go off, which means even more opportunities to learn about the stars and galaxies around us. For now, all eyes are on Coronae Borealis. Professional and amateur astronomers alike are eagerly awaiting the star's next move. If it does flare up, it'll be a powerful reminder of just how active and dynamic our universe is.
First, I'm going to look this up in Stellarium. I have it set to 10 p.m. with a wide field of view looking south. Okay, let me look up the Blaze star. It's towards the east, and it should be up most of the night. Cataclysmic variable star. Nice. Okay, let's change to the field of view of the C star, which I already have configured on my Stellarium. Okay, so we can see this is where the Blaze star is. But how do you get there? If you look it up in the C star catalog, it isn't there. You could try doing star hopping, or just look for IC 4587, which is a radio galaxy. So let's do that. See how close that is to T Coronae Borealis? Okay, so if you look up IC 4587 in the C star atlas, hit go to. Once it's centered, take a few-minute photo. I took a 5-minute one for good measure. This is what I got. And you can see it agrees with what we looked up in Stellarium.